Welcome to another tutorial. We're going to do question 2. A vertical pole BP stands at one corner of a horizontal rectangular field as shown. So ABCD is a rectangle and BP is this vertical pole stands on the corner B. AB is 10 meters as CD is 10 meters. This base is a rectangle. AD is 5 meters, so BC is also 5 meters. This angle is 22 degrees. This angle is called angle of elevation. It's above horizon. If it's below horizon, it will be angle of depression. Now, part A, let's use whatever is given to find these. Now part A, the height of the pole. The height of the pole is right here. The height of the pole means the length of this line BP. Now let's draw a triangle to represent this pole and see what do we have. So let's say this is this part of the diagram that we are working on. So here is A, here is B, and here P. This angle is 22 degrees as it's given in the diagram. This length AB is 10 meters. We are going to find this. Now, according to this angle, this side BP is opposite and the 10 meter is adjacent. Which trigonometric will help? Which trigonometric covers opposite and adjacent? Definitely tan. Tan of 22 is equal to opposite over adjacent. The opposite is line BP, this line BP, and the adjacent is 10. Now using a calculator, tan of 22 is equal to this 0.404. So let's write it. Tan of 22 is 0.404, which is equal to BP over 10. Now we need to get rid of this 10, so you're going to multiply both sides by 10. It means this number will be multiplied by 10. So it's better to use the whole decimal number here, not only 3 decimal places, because when we use all, it gives more accurate answers. Times 10 is equal to 4.04. This so nearly, since we cannot round these, we can just say BP. The length or the height of the pole is 4.04. They are all in meters. This one is also in meters. 4.04 meters. The angle of elevation of P from C. This time again we work on triangle. This time we're going to work on this triangle. P, B, C. This triangle. And we need to find this angle. Angle of elevation. This time angle of elevation of P from C. We're going to work on this triangle. In this triangle, this side is C, the side that has the angle of elevation. The angle is missing. We need to find it. But BC is given. AD is 5, so BC is also 5 meters. And this is P. We found BP, which is 4.04. How can we find this angle? As you see in the diagram of this triangle, two sides are given. One of them, according to this angle, one of the sides is opposite and the other side is adjacent. Then tan of angle C is equal to opposite, which is 4.04 over adjacent, which is 5. Now, since the angle is missing, let's divide these two numbers. 4.04 divided by 5. 4.04 divided by 5 is equal to 0.808. And let's write this. 0.808 is, and this is tan of C. Now it's time to use tan inverse. When I say tan inverse of 0.08, then we'll get the angle. Tan inverse of 0.808, tan inverse of this is equal to 38.9. This angle is 38.9, or simply we can say it's nearly 39 degrees. So the angle of elevation is 39 degrees. Part C, the length of a diagonal of the rectangle ABCD. Now we're going to work on this rectangle ABCD, and we are going to find the length of the diagonal A, B, C, D. As you see in the diagram, the letters are in this order, so we do the same. And now we need to find the length of this diagonal. This diagonal or the other diagonal, they have the same length. So let's do it. Now to find this diagonal, let's see what we have. DC is 10 meters and BC is 5 meters. We need to find the length of this diagonal. Is there any angle? No. So is there a right angle? Yes. It's right time to use Pythagoras. Then let's name this diagonal to be easier in Pythagoras. Let's name it x. In the Pythagoras, we say x squared, the diagonal square, is equal to 5 square plus 10 square. Then 5 square is 25 and 10 square is 100. This is x squared, so x squared is equal to 125. Now to get rid of this square, we need to take the square root of 125. The square root of 125 is equal to 11.18. So x means the length of the diagonal is 11.18. Now the angle of elevation of P from D. Now it means we need to find this angle. We need to find this angle which is between D and P, this angle. To find this angle, again, we need to illustrate a triangle to demonstrate what we are going to do. Then this will help us to find the angle easily. Now the triangle has a right angle. The right angle is right here. So we have to illustrate a right angle triangle, and then through this triangle we can find the angle that we want to work on. Okay, now this is D, here is B, and this is P. The diagram is very important. As we found, DB is the diagonal of rectangle ABCD, which is 11.18. So DB is 11.18 meters. And BP, we found it in part A, it's 4.04 meters. Now we need to find this angle. According to this angle, which sides are given? This is the opposite and this is the adjacent. We have to use tan to find this missing angle. Now tan of angle D is equal to opposite 4.04 over adjacent, which is 11.18. 11.18 is the length of this diagonal. Now, by dividing these 4.04 divide by 11.18 is equal to this, and we have to take tan inverse of this result to get the angle D. Now, tan inverse of the answer is 19.86. We can say it's 19.9. So this angle of elevation is 19.9 if we round the answer correct to 1 decimal place. Now we did all the parts. Now let's do this question. We have this diagram, A, B, R, Q. They make a rectangle together. AB, as it's a rectangle, AB must be equal to QR as it's given in the question, and they both measure 6 meters. BR is 4, it means AQ is also 4. RS is 2 meters. RS, this height is 2 meters. Now find BS. BS is this hypotenuse. According to triangle BRS, BS is the hypotenuse. Let's draw the triangle here and work on it. Now this is B, and here is R, here is S. BR is given in the question, it's 4, and RS is also given, is 2. Now we need to find BS. Since we don't know any angle in this triangle, we have to follow Pythagoras rule. Now BS, let's name it B small, just for simplicity. B square is equal to 2 square plus 4 square. Then 2 square is equal to 4 plus 4 square is equal to 16. This is B square. So B square is equal to 20. What about B without square? We have to take the square root of 20. Then the square root of 20 is 4.47. 4.47. So B small stands for BS. It means BS, this side, is 4.47. Everything here is in meters. This one is also in meters. Part B, AS, this diagonal. We have to find AS and AR. We have to find AR first, then we will be able to find AS. If we look at this triangle, because AS is a part in 2 triangles. If we look at this triangle, we need to find AR, then we will be able to find AS. But there's an easier way. If we look at this triangle, the side BS and AB and AS. Now in this triangle we know the length of 2 sides. We know the side, we know the side. It means we can find the third one using Pythagoras. Let's use this triangle again, and we're going to follow Pythagoras to find AS. To label this triangle, as it's here, the 90-degree angle is with the B, and this side is S, and this is A. What we need to find AS. BS, as we found in the previous part, it's 4.47. And AB is given in the question, it is 6. Now using Pythagoras, let's name this A small. Then A small square is equal to 4.47 square plus 6. square. 4.47 to the power 2 plus 6 to the power 2 is equal to 59.98, but this is the result of a square. What about a? We have to take the square root of this answer. 7.48 is the length of AS. Done. So AS is 7.48. Part C, angle BSR. BSR. This angle. It's between B, S, and R. So always when the question says angle, the middle letter is the one that has the angle. Angle BSR is here, so let's label this triangle and work on it again. BSR. We need to find this angle. Now to find this angle, we need to know the sides. BS is 4.47, BR is 4, and RS is 2. We know all the sides. To find this angle, we can use either sine, cosine, or tan because we know all the sides. Now let's use tan. Tan of angle S is equal to opposite over adjacent. Hypotenuse is the longest side, always. We cannot say this is the opposite. No, longest side is always hypotenuse. Then opposite is 4 over adjacent is 2. 4 divided by 2 is equal to 2. Then tan of S is equal to 2. Let's use calculator. Tan inverse of 2 is equal to 63.43. This angle is 63.43. Now angle ASR. ASR. This angle from A to S to R. Now this time we are going to find this angle. It is between R, this line, and this one. So we're going to find this angle. This angle is in this triangle. It's in the triangle ASR. So let's reduce this diagram to be something useful for part D. Now this is A. The right angle is with the R. This is A. This is R. And this is S. How we know the right angle is with the R? Because R is vertical on the ground and this side is on the ground, so this makes a 90-degree angle with R. As here, the 90-degree angle is with the R. Now, what we know, AR, we don't know how long is AR. RS is 2 meters, and AS, we found it's 7.48. Now we know two sides, and we need to find this angle. It's quite logical because two sides are given. Now, according to this side, this is hypotenuse, and this is adjacent. It means cosine. Cosine of angle S here is adjacent, which is 2 over hypotenuse, 7.48. The side is opposite according to this angle. That's why we cannot use sine or tan. We have adjacent and hypotenuse. That's why we have to use cosine. Now, 2 divided by 7.48. 2 divided by 7.48 is equal to this. And we have to find the cosine inverse of this result to get angle S. Then cosine inverse of this result is 74.49. This angle is 74.49 degrees. Part E, we need to find angle PAS. PAS, so it means we need to find the angle with the A, because A is the middle letter here. Angle PAS. Now look at this triangle. Which sides are given? We know this side, PS, is the same length as QR, which is 6 meters. AS, we found it in part B, it is 7.48. PA, we can also use PA. PA is the same length as BS, and we found BS in part A, which is 4.47. Now all the sides are given. We can use any trigonometric like sine, cosine, or tan to get this angle. So let's use sine. Sine of A is equal to opposite, which is 6 over hypotenuse. Hypotenuse is the longest side, 7.48. Now 6 divided by 7.48 is equal to this decimal, and to get angle A, we need to find the sine inverse of this result. Then sine inverse of the answer is 53.33 degrees. It means this angle PAS is 53.33 degrees. Done. The other questions are your task, because we explored all the necessary IDs for such questions using trigonometrics and Pythagoras and working on 3D diagrams. Thank you for watching.